What is up, everybody? Welcome to the 9th image recognition tutorial video. It's just image recognition now. We're not really going to do any more manipulation. We've got this video and maybe one or two other videos before I wrap this up. And in this video, what we want to do is, well, in the last one we made the create examples, which was kind of like a making of a database for the examples of the numbers 0 through 9. And I guess we didn't really call that, so that's okay, so we don't have to get rid of that. But now what we want to do is let's go ahead and just remove all of this. Now what we want to do is let's actually make a function to take a current image and then compare it to the database that we just made right here with create examples. So that's what we're going to do now. So we're going to come down here and we're going to define a function. We're going to call this function what num is this. And in this function we're going to have one parameter, and that parameter is going to be the file path. So what's the path to the file that we're actually talking about? Now the next thing that we're going to do is we're going to say matched array. That's going to be an empty array for now, but as we find matches, we're going to store it in matched array. So let me explain what we're actually going to do here. So what we're doing is kind of like, it's close to a neural network, but not really. It's not actually learning anything. What it's going to do is just compare. It's much like pattern recognition. What it's going to do is it's going to compare pixel by pixel and ask the question, is this white or is it black, and is it similar to one of these examples? And so each time it's the same thing, it will store it. So it's going to take that combination, basically, what of the colors that made up that pixel. So even if you had like 3 colors or 4 colors, it would do that. Now keep in mind, it's going to calculate a true or a false, basically. So a 0 or a 1, or a 0% or a 100%, right? As time goes on, if you wanted to make this a little better, you would engage in either a bit of blurring. So you would take the image and move it left and right, and then, like, say you've got, you know, a 255, 255, 255, you would instead do, you might put a value on either side of that pixel, right? Because, like, what if the image is the exact same image, but it's shifted over to 1 pixel? Well, this would obviously throw this system for a bit of a loop. So either you can make a system that centers the image just so by various rules. So it could either have its widest part, you know, touching the edges of this 8x8 box, or the tallest part, etc. So you could do something like that. But really, probably the better thing to do is kind of make a smoothed out version of the picture in numerical form, and then you could compare them. But depending on what you want to do, that's going to kind of dictate how you go about doing it. So basically all I want to do here is just show you guys a heavily thresholded comparison in whether or not it even works in this sense. So we've got matched array, and so each time an object matches, it's going to go into this matched array. And what we're going to do is match it to that number. But instead of explaining everything to how this will work, I'll explain it when we get there. The next thing that we want to do is we want to load up those examples. So we'll just say load examps. And that's going to be equal to open. And what do we want to open? We want to open that numrx.txt file that we just made. And we want to open that with the intention to read. And let's go ahead and just read it into memory. Now let's go ahead and do load, oops, don't capitalize that X. Load examps equals, and then we'll just modify this a little bit. We'll say load examps.split by new line. So basically it's just reading each item as a line, or each line as an item, basically, in this num array examples. So now the next thing we want to do is we want to eventually, we're going to kind of well, one, we're going to convert it to a list so we can use it, but then also we're going to eventually want to show this visually, but we'll get there. So we want to say I equals capital IMAGE dot open. We want to open that file path, so that's pretty familiar to you guys. Then we'll do IAR for image array equals np dot array I, that's familiar as well. And finally IARL is going to be IAR dot to list. And again, like what we did with load examples is we just use the exact same variable, right, to modify the original variable. Whereas here, each time we use something different, we could say maybe I, like down here, we could say I equals I np array dot or I. You wouldn't have to change this, but we do want two versions because we're going to use IAR for something, and we are also obviously going to use IARL for something. So just keep that in mind, that you could change that up, but that's why I didn't use the exact same variable for down here. Moving on, we're going to use in question. This is going to be the string version of IARL. And the reason we want to do this is, well, you wouldn't have to do it this way, but since we're going to, for the method that we're going to use, this will be fine. But again, I guess I'll explain that when we get to it as well, since we're still just defining a bunch of variables. So now let's make a for loop. So what we're going to do is we're going to say for each example in load exams. Now, at this point, you can do one of two things. Well, you can do one of like infinity things. But our load examples, in the way that we stored it, let me just scroll up here. For each example that it found, it wrote the line and then ended with a new line. So we're going to have a blank line at the end of our file. And this is really common with a lot of files that you're going to get, because this is how just the way people do it. Ideally, what you would do is you would come down here and you would have a trim function and you would trim away that extra line. But pretty much no one ever does that for you, and so you might as well just get used to not having someone do that. But one thing you can do is for each example in load exams, you could say if len each example greater than 3, right? So it should be greater than probably like even 2 or something, but we'll just leave it 3. It really ought to be a very long length. Anyway, you could just do something like that, and that way you don't have to worry about blank lines, and then sometimes like screw up lines and stuff like that. So anyway, we'll just do that for now. So the next thing we want to do is we're going to say split example equals each example dot split, and we're going to split by that double colon that we made. And just in case anybody's not following like right after watching that last video, let me bring up the file. So in case you're not coming straight off of that last video, this is the file in question. So we have the number, and this just means like this is the example. And so if you weren't using, like if you were doing letters, you would have, like say this was for a J, you would have a J here, right? Or if it was for a capital J, right? And so for numbers, you have that number there. For characters, you would just put the character there, right? That makes the most sense. But then like if you have like a person's face, well, you would just give them like a number ID or just an ID. Then it could you know, that face could be Jeff, or you could give it, you know, face number 540, right? So just keep that in mind. But anyway, this is the ID, and it just so happens to be the ID of exactly what it is. And then this is the creation of that ID. So anyway, I'm going to close out of this and not save it. Now, so anyway, we split it. So then what we're going to say is we're going to say current num equals split x, and that's going to be 0, so the 0th element or the first element. And then we're going to say current array, so for that whole array of that item, is going to be split x1. And the next thing that we're going to do is we want to get each pixel, right? Because we want to compare pixel to pixel. Now again, that's not the best way to do it. It will work, especially if you've got a good close-up. You've got a full, you know, you specify the parameters to be like that full size of the images that you're comparing to. As long as that is the case, this is totally fine. But later on, say you're wanting to, like for facial recognition, like for example in a camera, right, when you're taking a picture and it like puts squares around people's faces. Well, everybody's face is a different size. Sometimes the camera might be really close or really far away, and in the end that's just a function that normalizes everything and still compares based on the same pattern. So you would have to do that, right, if you were really in the business of doing image recognition. So I'm going to leave that to you. There may be a day where I make a video series on how to do that, But mostly I just want to get the basics of image recognition down. And so anyway, the next thing we want to do is we're just going to say each pix example. So each pixel in the example is going to equal current array dot split, and we're going to do something, again, not the most professional, but since we're doing a very basic tutorial, we'll keep it as basic as possible, and this will keep us from writing another function. And we're just going to split by closing brackets, comma. So let me bring up that file again and explain why we're doing it this way. So here's our file again, and as you can see, if we split it just simply by comma, we're going to split by here, 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 and so on. If we split by bracket comma, however, we will split it, here, and then here, and then here. But luckily, the array itself, right, like every array starts with bracket, 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 and then first pixel, bracket close, comma, space, you know what I'm saying? So, of course, y'all can't even answer me, so I don't know why I ask. But anyways, they're all going to be that same, and since we are comparing only pixel to pixel, this is a fine way to do it. But again, if you wanted to expand this and make it a little bit more dynamic and versatile, you would have to change this, of course. So I recognize that, but for now, this does the job, and it keeps it very simple. So now the next thing, each pix, and then we're going to call this I capital, well, it doesn't matter, you can call it whatever you want, but I'm going to say each pix in question like that, equals in question dot split, and again, we're going to split, of course, by the same thing, otherwise there would be no matches. So that's that. Now what I want to do is make a while loop to run through all of the examples, because we never really know how many examples we're going to have. And you could write a for loop in like a one-line function and make it all fancy, but to keep things, again, very simple, let's just make a while loop with a counter. So we're going to say x equals 0, because we always start with the 0th element in the array. So then what we can do next is we say, well, while x is less than the length of each pix example, or you could do the length of like each pix in question. It doesn't really matter, but for each pixel, we're going to make this little while loop, and we're going to say, because in our case we have an 8x8, so we know there's 64 pixels, but in the case of an even larger one, so there's no reason to say like for each number in 0 to 63 do this. Doesn't really make much sense to do it that way, because we can do it this way with just as many lines and actually make it at least dynamic, so the whole thing isn't poorly written, right? So we're going to say that, and then we're going to say if each pix x, or each pix in the example with the x index is the same, so double equal sign, each pix in question with the x index. So if they are identical, we're going to say matched array dot append, and what we're going to append is the literal integer value of current num. Because natively it'll read it in as a string, since it's all coming in as a string and then being split up like it's a string. So so then what we'll do is we'll just match it to the integer of the current num, or we're going to append that integer to the array. So now, and that's this matched array. So now, after we're all done there, and closing that if statement, we want to do x plus equals 1. So make sure that's not under here, otherwise your program will be really finicky. It'll actually fail. So anyways, coming down, once you've done that, now let's just go ahead and, not under here, but I think one more over, right? So in the for, if len, for each, let's see, I think what we want to do then is put this underneath our for. So once the for loop is completely completed, let me get it over there. We're going to go ahead and let's print matched array, and then we're going to say, well, probably the easiest thing to do, let's see, I don't think we did it, yeah, up at the top of your script, what we're going to want to do is import this thing called counter, and it'll make this really nice array and do exactly what we want to do. So just type in from collections, import counter. Now I believe this comes with your vanilla installation of Python. I'm not absolutely positive. In fact, let me Google it really quick, because there's a lot. I've been playing with Python for a while, and that might not have come natively. One sec. Anyway, just wanted to make sure that was truly the case, and it should be the case that it comes with your installation. Coming back down now, what we want to do is we're going to say x, even though we have an x here, that should be fine. X equals counter of matched array. And what counter is going to do is it's going to go through that array and it's going to count, because like basically what's going to happen here is ideally you're going to have like a bunch of let's say you're inputting a number 3 and your array is working the way you want it to. Chances are there's going to be a lot of this is a typo, let me fix that. There's going to be a lot of pixels in the 3 example, or like the examples of the number 3 that are going to be matches. So there's going to, in this matched array, there should be a bunch of 3s. So what counter is going to do is for every individual quote-unquote type of element within your array, it's going to bunch it all together, and it's just going to give you one version of it followed by a colon, and it's really going to make like a dictionary kind of. And it's going to be like that number, colon, and then how many times it was found in the array. And then what we can end up doing is graphing that. So, but also you don't even have to graph it. It gives you your answer, which one is most closely related to what we're doing, right? So x equals counter, whatever, and then we can print x. And just for a simple example, let me bring over a Python module here. So we're going to do from collections, import counter, and we're going to say example equals 1 1 2 6 4 2 2 6 1. Good. Now we're going to say C for collections equals counter x, and then we'll say C. So now what it's doing is it says for the number 1 there are 3 examples. For the number 2 there are also 3 examples. For 6 there are 2 examples, and then we have in a number 4 and there's only 1 example. So it looks very much like a dictionary. By the same standards, you can do like C, and we want to know how many examples of the number 1 there are, and then it outputs 3. So that's a little bit of how they work. It's basically a dictionary. So close this out, and that's that. So now what we want to do, we're not calling any functions. So what we want to do is we're going to call what num is this, and we're going to put in that file path. So what num is this, and the file path is, you followed my directions, images /test.png. Save that, and let me bring up that image real quick. And actually, I thought I included a test image, but I guess not. Okay, so what you want to do is open up Paint or whatever you have to make silly images, and make sure you do a save as, and save it in images, save it as test.png or whatever you want to. And so the next thing we want to do is let's actually make an example. So I'll just click on the little pencil here, and let me scroll this over, and let's make let's do a number 3, since that's pretty difficult. So okay, oh my gosh, this is a very bad 3. I'm not sure this is gonna work, but that'll be nice if it does. So anyways, that's my 3. Let's just I guess we'll leave it there, whatever. Anyway, we'll see what happens. So I'm gonna save that as test.png. We'll move this over, and hopefully we didn't really check this for integrity or anything, but I guess we'll find out. So let's run this and see what we get. And we'll move this over, and we can see here that it didn't indeed correctly pick the right number. Now, just as an aside, it's an 8x8, so there's 64 possible matches per example, and we have basically 64. Well, yeah, you got 64 pixels. And then each number has a total of 576 examples, so like a quote-unquote perfect match would be 576. So this scores a 427 out of 576. This scored a 400, and so on. So I would argue that it must be better than surely 400, right? So you might want to like threshold at 400. Anything that's worse than a 400 match, it's a high probability that it's wrong. Anything above 400, you're getting closer to the fact that, well, then maybe this is correct. So anyway, luckily with my horribly drawn number 3, we were able to actually have a match. I didn't think that we would get it with this nasty 3, but somehow we did it. So anyways, that's that. And just as a quick aside too, counter, we'll always put like the highest number first, right? So the most matches was for number 3, the second most was for number 2, and so on. The least matches was a number 1 with only 309. So that's cool, but everybody likes to view things visually. So in the next video, what I'm going to be showing you guys is a visual representation of this, and then we'll actually run some more examples with some awesome hand-drawn numbers by me. So anyways, as always, thanks for watching, thanks for all the support, the subscriptions, and until next time.